Hi everyone, good morning. Hope everything is fine with you people. Seeing you after a long time. So we'll see the module comprises of uninterruptible power sources, constant voltage transformers, static compensators and static var compensators. First of all, what is a UPS? Uninterruptible power supplies are devices which are used to supply electrical loads from the commercial power means during normal operation, and as a backup from a standby source during standby operation. So we'll go to our slides. I repeat, what is an uninterruptible power supply? So why it is provided? It is to provide clean and stable power to load regardless of power grid condition. UPS have been widely used for office equipments, computers, communication system, medical life support, and many other critical systems, as you know. Market requirements include a target expectation for UPS of reliability 99.99%. So figure shows a double conversion online UPS. So what is a double conversion online UPS? So the design offers a double power conditioning process. Rectifiers purifying incoming AC power to DC power and to supply the UPS DC bus. The output inverter takes the DC power and produces a regulated AC to support the critical load. Now we'll see the performance of UPS for various power quality problem. So the power quality problem is listed on the side. What is temporary interruption, long-term interruption, momentary interruption, sag or under voltage, and the corresponding waveform is shown. Whether the UPS will be able to solve this in offline and online. That is shown in the table. And the other power quality problems like swell or over voltage, transient impulse or spike, notch, noise, and harmonic distortion. The corresponding waveform is shown, whether the UPS will be able to solve that particular problem or not. Effectively, comparison of the performances of UPS proves that the double conversion online UPS can improve power quality to a great extent, feeding power to any type of load. But is it a source of harmonics? A double conversion online UPS has low power factor and excessive nonlinear currents during its normal operation that can generate harmonic currents back into the upstream or utility line. At the same time, a low power factor UPS is less efficient and lead to overheating and cause a reliability problem. So the choice of UPS can be either it is as a source of harmonics or it is a source of green power. Conventional UPS draws power from only a brief peak voltage segment of the supply waveform, which can cause distortion and drain as much as 40% more power than the UPS current rating would suggest. UPS with power factor correction circuit achieves near unity power factor by drawing current in a linear fashion in relation to the voltage throughout the entire sine wave spectrum, thus reducing power consumption. So as a UPS as a harmonic generator. The presence of harmonics in the upstream of UPS is due to the fact that it draws power from the upstream AC into a SCR rectifier followed by DC capacitors forming RCD type load. The most common type of rectifier or chargers are based on a gates bridge with SCRs combined with a very high impedance smoothing inductor and DC capacitor to get smooth DC voltage. So power factor correction front-end UPS as a power conditioner. Power factor correction makes complex AC loads act more like simple loads. The power factor corrected circuit in UPS compensates for the impedance and makes the load linear because power factor correction is needed. So what we require? We require a pure resistive circuit. So active power factor correction is to make the input to a power supply look like a simple resistor. If the system dynamic impedance is made resistive, then the power factor will approach nearly unity, as you know. Now we'll see the comparison of an SCR front-end UPS versus a power factor corrected front-end UPS. The first one, that is full bridge SCR front-end UPS, it uses passive elements, that is inductor and capacitor, at output of the rectifier to reduce AC components in DC voltage. Power factor is less than 70%. The harmonic and significant electromagnetic noise can result for THD, the total harmonic current, as greater than 40%. Active PFC front-end UPS uses switching regulator technology. Switching regulator technology means we use IC, FET, diodes to create a power factor correction circuit. And this circuit has a power factor of 95%, reduces the total harmonics noticeably and automatically adjusts the AC input voltage. Now we'll see the benefits of power factor corrected UPS. The first one, the boost rectifier in the input adapts to a wider input window. Marked improvement of AC mains or utility power quality in medium and high power application. Reduces input cable size and switch gear rating due to reduction in input current. Conversion of energy. Helps in reducing air pollution by virtue of less fossil fuel reduced for generating same amount of electrical power. Lower I squared R loss or improved reliability, steadier terminal voltages, reduced cable and switchgear sizes. Active PFC front end also helps to meet the IEEE standards. Now we'll see in detail an uninterruptible power supply. A simple block diagram of an uninterruptible power supply is shown in figure. So it consists of a standby source and a standby auxiliary, which is connected to commercial means. So the main function of standby source and its auxiliary are to provide the energy source for the operation of the load during standby operation. Standby sources usually categorized into two. One is rotating type and the other one is non-rotating type, that is static. Rotating sources, first you will see rotating sources, which is having the following characteristics. Rotating sources consists of diesel, gasoline or jet turbine, which is shown in the table. The engine drives an alternator, which may be excited by a small DC machine or a battery. Maintenance may present problems because of inherent problems associated with rotating machinery. Size, weight, and portability are disadvantages due to inherent size and weight of reciprocating engines and synchronous generator. And third point, a supply of fuel is required. Most installations have a regular maintenance schedule and regular testing schedule. Isolation from line is excellent in standby mode, and rotating UPS may be the only alternative for higher power levels and most of the three-phase application. Now the second one, that is static type, non-rotating type or static type. The static applies to non-rotating devices. Static UPS uses battery as the energy source for the standby mode. Static UPS, now it will see the characteristics of static UPS. One, the total energy available is usually much more limited than in rotating UPS. Units may require special ventilation and maintenance due to battery requirements. Also, larger units may require specially placed battery rooms. Some static UPS require specially designed battery charging units. All static UPS involve the use of inverter, and these inverter incorporate power semiconductor devices. So the main disadvantage of static converter is the use of a battery. Batteries have limited life energy storage capacity, and the cost and size as calculated per watt hour stored may not be competitive. The table shows the characteristics of both static and rotating standby power sources, as I already explained. Now static converters. Static converters are mainly divided into two. One is floating charge unit and the other is rectifier inverter type. Both are shown in the figure. So the first we will discuss the floating charge circuit. The floating charge type contains a dedicated charging unit. This is energized by the line. The charger may be a simple trickle charger, consisting of mainly a transformer, rectifier, and resistor, or it may be of a much more complex design. Some models also incorporate a state of charge meter. So what is a state of charge meter? It's a digital meter. The state of charge meter may be a digital timer which count down the battery use and charge time, or they may operate on a more exotic basis, such as the evolution of total charge passing through a conductor. The main advantage of floating charge configuration is one of the simplicity of the charge circuit. Also, there may be some advantages to battery life and efficiency, since the rectifier used carries a very low power level in the floating charges. Now the second one, that is rectifier or inverter type. The main advantage of this is that the battery is always there in the circuit. It is always powering the inverter and there is no transfer switch is required. The design, cost and life of transfer switch is a main consideration, since this switch carries full load power. Also in rectifier inverter type, there is no required circuitry which detects outage of commercial mains. So the battery simply powers the inverter all the time, including times of power failure. The main disadvantage of rectifier inverter design is the need for a rectifier at high power level. The rectifier translates into both cost of semiconductor and cost of power lost in the rectifier. And there is no clear rule or guideline on which design is preferred. Now we will see the transfer mechanism of UPS. All rotating UPS require a transfer switch whose function is to transfer the load from the main supply bus to standby source. The transfer switch must carry full load and it must be overrated in order to allow transfer of inductive loads. The transfer switch must be mechanical. At lower levels, through a few kilowatt, an electromechanical relay may be used. But at high power levels, mechanically operated switch may be used. The important point is that load must be transferred as soon as possible to the standby source. For high power applications, circuit breaker must be used for the transfer switch. In case of a static UPS, some design do not employ a transfer switch and there is no need for sensing circuits which determine when a transfer is necessary. But the floating type UPS always require a transfer switch. And the UPS uninterruptible power supply state diagram is shown in the figure. Now another complex design of UPS, that is a floating charge UPS. In floating design, the battery charge current may be modulated in order to lengthen the battery life and increase the overall efficiency. A typical design is shown in the figure. Now we have different tables which represents the specification of small, medium and large UPS. So a typical specification of a 1 kVA UPS, its power, standby power, how the transfer is done, its operating time, features and size. Similarly, for a 30 kVA UPS, its power, standby power, transfer, time, features and size. Similarly, for a 250 kVA UPS, its power, standby source, transfer, how the transfer is done, and time, features and cost.